Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 818 race car. Your car starts at position 0 and speed +1 on an infinite number line. Your car can go into negative positions. Your car drives automatically according to a sequence of instructions. A means accelerate and R means reverse. When you get an instruction A, your car does the following. Position is updated to position plus speed, and the speed is updated to double of the original speed. When you get an instruction R, your car does the following. Your first speed is positive, then speed equals -1, so reverse. You are going to travel in the reverse direction. Otherwise, the speed equals 1. So if your speed is negative, then you update it to +1. And your position stays the same. For example, after command AAR, your car goes to position. So first, your car starts at position 0 with speed 1, and then when you got the first instruction A, the position of the car is updated to position plus speed, that's 0 plus 1. So your position updated to 1, and then your speed is double, so that's why your speed is updated from 1 to 2. And now you are considering the second instruction. The second instruction is again A, so in this case, your position is updated to the position 1 plus speed 1 plus 2, that's 3, and then your speed is doubled, so it went from 2 to 4. And then the next instruction is R. So in that case, your position stays the same. That's why it's from 3 to 3 stays the same. And speed got updated to the -1 because before this R instruction, your speed is a positive number. So now the problem asks you to return the length of shortest sequence of instructions together given the target position. In the example 1, target equals 3, the output is 2. The shortest instruction sequence is AA. Your position goes from 0, 1, 3. And then how it got updated to 0, 1, 3, we already covered in the previous sequence AAR. The second example, the target is 6, output should be 5. The shortest instruction sequence is AARA. Your position goes from, like, say, initially 0, got updated to 0, 1, 3, and then from this 3, your speed right now is 4. So that's why when you encounter another A, the third A, your position got updated to 7. And then now you encounter reverse instruction, so R, so your position stays the same, and your speed got updated from positive to -1. And then the next instruction is again an A. So in that case, your position got updated to position plus speed. That's 7 plus -1, that's 6. So you reach your target position. So how to solve this? So at the first glance, this is a variation of the shortest path problem. So the approach for solving shortest path problem is BFS, breadth first search. So we can consider the naive breadth first search. So that requires the time complexity is O, 2 to the power of n. Why? Because for the naive implementation of breadth first search at each position of the instruction sequence, you can choose A or R. So because basically for each move, you can go accelerate or reverse. But apparently, this one is not really optimized solution. So to optimize, we consider the BFS with greedy algorithm. So as long as we haven't reached this position, we just keep accelerate. But we need to think about when to reverse. There are two different scenarios. Let's suppose now you're already traveling in positive speed. So you are actually moving towards the target position. And then in the next move, if you keep accelerating, and then the next move is going to move past this target. So in that case, before making that accelerate move, you may want to reverse. And then second, so you are already traveling in the negative speed, which means you're already moving in the reverse direction. So you are moving reverse direction. So for example, if move the target and then the next move is going to move to the left of the target position. Let's say your target position is 8, and then you are moving to the left. So next move is going to move to a position less than 8 if you keep accelerating. So in that case, in the current move, we may want to consider a reverse. So those are two different scenarios you may want to reverse. So that's kind of simplify the moves and then optimize on top of the naive BFS solution. So let's code it up. So we use the Python double-ended queue, DQ, and then we have, let's have a queue equals DQ. And then initially we should have our start position, so which the position is 0, and then the speed is 1. And then the current number of instructions is 0. We do not have any instructions yet, so it is a queue of position, speed, and the length of sequence. And then we also have a visited. So basically this visited contains the set of position and then speed. So while queue, the position, speed, length equals q.pop left. And then if this position, speed already in visited before, we just continue to the next element to pop the next element from the queue. Otherwise, we kind of determine the next move. So to determine the next move, we just append, let's say if next, let's just try to append that to queue. So queue.append. So accelerate position plus speed, speed times 2, double the speed, and then also length plus 1. So you add another instruction. So consider reverse. Let's say if your speed is greater than 0, so you are traveling, moving towards the target position, and then your next move, position plus speed, is going to move past the target. In that case, you append, you do the reverse. In doing the reverse is position, same position, and then we need to determine the speed. So here we append the speed. So since we have the speed greater than 0, so we append the speed -1, and then we do the length +1. Or if your speed is greater than 0 and then your position plus the speed is going to be less than target, you need to do the reverse. So q.append position, and then your speed becomes +1, length +1. We actually do not need those parentheses. So those are the two cases for the reverse scenario. So in this queue, when we pop something, we need to check if this position, let's say if this position equals the target position. In that case, we just return the length, which means we already find our solution. We already reached the target. So not reaching target yet. Cool, so this is our solution. So let's try run it. Yeah, so basically, let me recap the solution for this one. I'm using a optimized BFS with the greedy algorithm thinking. So we just keep accelerate, trying to reach our target position, but we consider when to reverse. So we may currently travel in positive speed, and then the next move is going to move past target if keep accelerating. In this case, at current step, we are considering reverse. And the second scenario is we are currently traveling in negative speed, and then for the next position, if we continue accelerating, it's going to be moved to the left of the target. So which means, okay, we are moving away from target again. So in that case, we are considering trying to do the reverse operation, trying to do the reverse. So basically, we keep accelerating and then only consider the reverse options in those two scenarios. And then the rest will be pretty standard BFS with Q and keep track of the position and the speed already visited.